Indeed, if you could predict a future defect early, most of these defects could be avoided. Let us compare the steel production process with a Galton board. Balls are falling down a board with pin obstacles. The balls follow a certain route into a final basket at the bottom of the board, such as a production order follows a production process from iron ore until a finished product. On these routes towards the finished goods, defects can occur on the way down. If we could predict the defects early, we can avoid most of the defects to occur. You can, for example, avoid the defects by selecting another production route. For example, select a production route with a more modern and better performing galvanizing line. This can be handled by production planning if such a defect is predicted in time. Or we can re-engineer the remaining production steps and its processing parameters to avoid the defect. For example, slowing down the coating process for this coil to avoid a coating surface issue. Or insert an additional rework step to prevent or cure the defect. Or we can reassign the material unit that is predicted to result in a defect to another but less demanding production order. For example, some not so visible car parts demand less surface perfection than other car parts. As a matter of fact, the earlier we can predict a defect, the more possibilities production management has to avoid the predicted defect. This defect prediction would allow us to reduce the defect rate drastically and even evolve to zero defect metals manufacturing. But how can we predict defects that will only appear in the future? Can we learn to predict the future from the past? Can we learn to foresee future defects by looking at past defects? A promising prediction technique is to use machine learning models, which exhaustively explore all possible combinations of how production factors affect quality metrics and defect types. Based on historical defects and all its related process and production data, a defect prediction model can be extracted in order to predict future quality defects as early as possible and hence can be avoided. In one of the remaining videos, we will explain how these machine learning techniques can be industrialized for daily operational defect prediction.